All right, good morning, guys. Let's go ahead and begin. So, with this proof, we're given that DB is perpendicular to AC and that M is the midpoint of AC. We would like to prove that segment AD is not congruent to segment CD. So, first what we're going to do with this is we're going to assume the negation of what we're trying to prove. So we're going to go ahead and assume that AD is congruent to DC. And if that's the case, then triangle ADC would be isosceles. So that's how we're always going to start these off. We're going to assume the negation of what we're trying to prove. Now, if this is an isosceles triangle, then segment DM would not only be the altitude, but it would also be the median. Because within an isosceles triangle, the altitude and the median are the same exact line. So, both the median and altitude should intersect at the same point. But looking at this, we have point M for the median and point B for the altitude. So these are not intersecting at the same point. Therefore, AD cannot be congruent to CD unless point B and point M are the same exact point. Now, this is what we call an indirect proof, and that's exactly what we're going to be covering today. All indirect proofs will be paragraph proofs, and they'll all have a very unique style of writing them. And we'll see this style in just a minute, but it's going to be very consistent every time that we do these types of proofs. So, let's go ahead and get started. All right, so today we're going to be doing 4.6 indirect proofs. Our learning target is I can perform an indirect proof, which we just did on the previous page. So let's go ahead and get started. So, here is our indirect proof procedure, and it's very important that we know all of these because we're going to be using them constantly. So the first step that we have is to list the possibilities for the conclusion. Either the conclusion is what we're trying to prove. So the conclusion can either be true or false. There's no other choices. So that's what we're going to start off with. We list either our conclusion is true or our conclusion is false. From there, we assume the negation of the desired conclusion is correct. So if they tell me that I need to prove two things that are not congruent, I'm going to do the opposite of that, and I'm going to prove that they are congruent. So that's what I would assume at the start. I assume the negation of whatever we're trying to prove. Our third step, we just start proving that the triangles are congruent, or we start doing a chain of reasoning until we reach an impossibility. And these impossibilities will just be a contradiction that occurs. The contradiction can be either from the given information or from a theorem, definition, or known fact. Oftentimes it will be from the given information, but sometimes you will see it through these other things as well. After that, well, if we ran into a contradiction, then that would mean that our initial assumption was false, so therefore our remaining possibility must be the only other outcome. And since that is our desired outcome, that would finish up our proof. So let's go ahead and see what one of these looks like, and then we can actually see it in motion. So, given angle A is congruent to angle D, and segment AB is congruent to segment DE. Also, AC is not congruent to DF. We would like to prove angle B is not congruent to angle E, and that should be a not congruent here. So, we start off with our two choices. Either angle B is congruent to angle E, or angle B is not congruent to angle E. Those are the only two choices. Now, since we're trying to prove that they're not congruent, we're going to choose the opposite choice. So we're going to assume that angle B is congruent to angle E. Well, if that's true, then we can go ahead and say that angle A is congruent to angle D, and segment AB is congruent to segment DE. All that's from our given information up top here. Now at this point, I can prove that the two triangles are congruent using angle, side, angle. So triangle ABC is congruent to triangle DEF by angle, side, angle. If the two triangles are congruent, that means that the corresponding parts are as well. So I would then be able to say that AC is congruent to DF. However, this is a giant red flag for us. Now, these two segments are congruent by CP/CTC, because if the triangles are congruent, then the corresponding parts are congruent. But this is a big red flag. And the reason for this is because in our given information, it clearly says that AC is not congruent to DF. So this is a contradiction. This is our contradiction, which makes this impossible. So because AC is not congruent to DF from our given, our assumption is false. So this assumption that angle B is congruent to angle E is false because we ran into a contradiction, which means that if our assumption is false, angle B cannot be congruent to angle E. That's the only other option here. So since that's our only other option, angle B must not be congruent to angle E, and our proof is complete. So that's what an indirect proof will look like. Again, we list our options, we assume the negation of what we're actually trying to prove, and then we go ahead and we do a chain of reasoning until we hit our contradiction. Once we hit our contradiction, we state that our original assumption is false, and therefore the only other option, our desired outcome, must be true. Let's try another one out. In this one, RS is perpendicular to PQ, so they intersect at 90 degrees. PR is not congruent to QR. We want to prove that RS does not bisect angle PRQ. So we start off with our two options. Either RS does not bisect angle PRQ, or RS does bisect angle PRQ. Those are our only two options. We're going to assume the negation of what we're trying to prove. So we're going to assume that RS does bisect angle PRQ. Well, if that's the case, then I can say angle QRS is congruent to angle PRS. Because if we have a segment that is bisecting an angle, it's cutting it in half. If that's the case from our given, we know that RS is perpendicular to PQ. So therefore, we can say that angle PSR and angle QSR are right angles, and we know that all right angles are congruent, so they're also congruent to each other. Now, there is something that's shared by both triangles, and that'd be segment SR. So we can say that RS is congruent to RS by the reflexive property, which would then allow us to say that these two triangles are congruent. So triangle PSR is congruent to triangle QSR by angle, side, angle. If that's the case, if these two triangles are congruent, then PR would be congruent to QR by CPCTC. However, that is a contradiction. This is impossible, because in our given, it clearly says that PR is not congruent to QR. So therefore, RS does not bisect angle PRQ, since that is the only other option available. Because again, our assumption was false, we need to go back and say, since our assumption is false, the only other option must be true. The only other option is that RS does not bisect angle PRQ. And with that, this proof is complete. All right, time for our final one. Given circle O and AB is not congruent to BC, we want to prove that angle AOB is not congruent to angle COB. So, to get started on this one, go ahead and pause the video, try this one out, and then we'll go ahead and do it together in just a minute. So, starting off on this one, we have two choices. Either angle AOB can be congruent to angle COB, or angle B is not congruent to angle COB. We're going to assume the opposite of what we're trying to prove. So we're going to assume that angle AOB is congruent to angle COB. If that's the case, then AO is congruent to OC because they're both radii in a circle. Further, OB is congruent to itself by the reflexive property, which would make triangle AOB congruent to triangle COB by side, angle, side. Well, if these two triangles are congruent by side, angle, side, then I should be able to say that segment AB is congruent to segment BC by CPCTC. However, this is a contradiction because AB cannot be congruent to BC. So therefore, our assumption must be false. And that would mean that angle AOB is not congruent to angle COB because that is our only other option. Because again, it can't be somewhat congruent. It either is congruent or it's not congruent. And with that, this proof is also complete. All right, so that is it for our notes today over 4.6 indirect proofs. Again, our learning target is I can perform an indirect proof. Thank you guys so much for watching. If you do have any questions, please let me know. But I hope that you have a great rest of your day. Thank you.